Hey guys, Mr. Wilson here. Today we're looking at areas of regular polygons. Number 2 notes. At the end of this video, you should find the area of a regular polygon using trig. Okay, in the previous lesson, we derived a formula for finding the area of a regular polygon as area equals 1/2 apothem times perimeter. Okay, the three shapes that we used were triangles, squares, and hexagons. And we did that because these three shapes made special right triangles when using the apothem and radius. Okay, what happens when a special right triangle is not made? Okay, let's look. This is a regular 1, 2, 3, 4, 5 pentagon. Pentagon. Okay, so as we look at a regular pentagon, XCZ, they ask us what angle or what's the measure of angle XCZ. Remember that we can find that central angle by taking 360 and dividing it by the number of sides. So in this case, 360 divided by 5, and that gives us 72. XCZ would be 72 degrees. Remember, that's not really what we're looking for. As we use our triangle, we're more looking for YCZ, which should be half of 72, which is 36. We can find out from this pentagon the perimeter already, right? Because it's a regular pentagon, it means all the sides are the same, and they told us that one side is 8 centimeters. Then we can find the perimeter by saying 8 times 5, which is 40. Okay. How do we find the other piece that we need, right? Because our area is 1/2 apothem times perimeter. And since we have the perimeter, we have to use trig to find our apothem. Okay, so this is how it works out. We are going to look at this triangle, YCZ. Okay, because this whole side was 8, remember the apothem splits that side, that must mean that this will be 4. We found that this angle was 36 degrees. And so we can find our apothem by using our trig functions. Okay, and in this case, we have the adjacent side and the opposite side that we're using. And so we use tangent. So we'll say tangent 36 equals opposite over adjacent. And that's the A for apothem here. And so to get A by itself, A equals 4 over tangent 36. Okay, so what's the exact value of this piece? 4 over tangent 36. Okay, so now that we know that, it says what's the area of this polygon to the nearest 10th? What we can do is we can plug that all into our formula. Area equals 1/2 the apothem, which is 4 over tangent 36, times the perimeter, which is 40. So doing that in my calculator, 4 divided by tangent 36 gives me some number like 5.5, but I'm just going to leave that whole value in the calculator. Then I'm going to multiply it by 40 and multiply it by 1/2. And that gives me, this whole formula calculated, 110.1 centimeters squared. All right. Next example, it says find the area of a regular octagon with a radius 9 feet. Give your answer to the nearest 10th. So here we go. We have an octagon. That means it's 8 sides. Okay, and you can focus on drawing the 8 sides if you like to. Okay, 8 sides. But really what we're going to be focused in on is this triangle that's made. So the center, the radius gives us the distance from the center to one of the vertices, 9. And we need to find 2 pieces of information. For our formula, we need to know the apothem, the perpendicular distance from the center to the side, and the perimeter, sum of all the sides outside. Okay, so in order to do that, we need to know what this angle is. We can find this angle by doing 360 divided by 8 to give us our central angle. 360 divided by 8 will equal 45. Okay, but remember that that is the whole central angle. For the triangle to find the apothem and the half side, we only see half of that. So 45 divided by 2 is 22.5. Okay, so as we zoom in, and I say zoom in, but I'm just going to draw it bigger. On the triangle that we're using, we know that the hypotenuse is 9. This angle being 22.5, we need to find our side, call X, and our apothem, which I'm going to call A. Okay. And we can do both of these by using our trig functions. So to find X, this is my opposite side. I know my hypotenuse, and so I'd use opposite hypotenuse sine. Sine 22.5 equals opposite X over hypotenuse 9. Okay, so to find X, X is 9 times sine 22.5. Okay, and you'll see that about 3.4. Okay, if we're rounding it. Okay, 3.44. Okay, moving on to find our apothem. Our apothem, I'll use pink for that. Our apothem is the adjacent side, and we know our hypotenuse, so we say adjacent hypotenuse cosine. Cosine of 22.5 equals adjacent A over hypotenuse 9. 9 times cosine 22.5 should give us our apothem. And that is 8.31. Okay. Okay, so we have enough information to start to plug in our formula. Okay, as we look at our area equals 1/2 the apothem, which is 8.31, times our perimeter. Now we haven't found the perimeter yet. Okay, remember we just found X. That's half of one side. So what we have to do is multiply it by 2 to get the whole side. And so as I go back, that times 2. Our whole side should be something like 6.888. Okay, so this is 6.888. And there are 8 of those sides. It's an octagon. And so we find our perimeter is 55.1. 0.6. Okay. So area is 1/2 the apothem times our perimeter, which should give us 228.96. And so we'll say 229.0 as we round to the nearest 10th feet squared. Okay, because these numbers get larger and larger and larger, it's best for us to try to not round our answer. So if we can use these values, which we can, in our equation, it'll make our answers that much more accurate. Okay. We got this next one is going to seem a little unconnected to what we've been doing, but we're doing it now because it involves area and trig. So not a regular triangle here, but we'll be able to find it. Okay. In the triangle below, we know that B, C, and measure A, all the things in blue. Okay. We can find the area of a triangle by doing this. Area equals 1/2 B times C, where those are side lengths, times sine A. Remember, this is one whole value together. Okay, 1/2 BC sine A. Okay, and what that really does is we look at our formula, sine A, 1/2 BC sine A, we are able to use our base, find our base, and then C sine A should give us the height. And so we have 1/2 base times height. Okay. And so here, as we're looking at this triangle, we have sides 12 and 26, okay, and an included angle. And notice here that we had that A was an included angle. And so we can use this formula as A equals 1/2, we'll just call it B times C times sine A. Okay, and so as we do that, A equals 13 times 12 times sine 76. Again, you can do that however you want to do that. 13 times 12 times sine 76. And that should give us 151.36. So 151.37 millimeters squared. To the nearest hundredths. Okay, number 2. Doing the same thing here. They give us a little bit more information, and really, it's more information that could throw us off, but we're going to remember that B and C are the sides that include the angle. So 1/2 9 times 17 times sine 67. Okay, so as we do that, 1/2 times 9 times 17 times sine 67. And that gives us our area as 70.42 inches squared. All right, so we found out how to find the area of a regular polygon, any regular polygon, not just triangles, squares, and hexagons. And then we found another way to find the area of a triangle using area equals 1/2 BC sine A. All right, see you.